All right, so now let us investigate whether there is an increased risk of cancer in dogs that were exposed to the herbicide 2,4-dichlorophenoxyacetic acid. Let's say 2,4-D. A study in 1994 examined 491 dogs that had developed cancer and 945 dogs as a control group. Of these two groups, researchers identified which dogs had been exposed to 2,4-D in their owner's yard. And you see the results in the table below. So first off, is this an experiment or an observational study? Well, they're looking at dogs who have owners. This is going to be an observational study. They found the dogs that have cancer and then found a group that didn't have cancer. They didn't randomly choose which dog had cancer. Anyway, are the conditions met? Well, if you look at the sample sizes, all these numbers here, all of them are over 10, so the sample size is certainly large enough. However, if you notice in the wording, there is no mention at all about random selection or random assignment, so independence is not really clear in this case. So the results of these, you should be kind of careful in terms of not reading too much into these results. All right, so what about hypotheses? To test whether 2,4-D and the occurrence of cancer are related. First, our groups are going to be the cancer group and the no cancer group. So PC minus P and NC. The null hypothesis would be that the difference in proportions, the proportion from the cancer group minus proportion from the no cancer group is equal to 0. The alternative is that the difference in proportions is not equal to 0. Okay. Now, the point estimate is standard error. Well, for the first group, let me see, like 191 divided by 491 comes out to be 0.389. For the no cancer group, the proportion is 304 divided by 945. So for the no cancer group, it was about 32.2%. So the point estimate would have been the difference of those proportions, 0.389 minus 0.322, comes out to be about 0.0673. So that is, if I take that one, the first one, subtract off the second proportion, I get a difference of 0.0673. As for the standard error, that'd be the square root. The first point estimate was 0.389 times 1 minus 0.389 divided by the first sample size is 491 dogs in the cancer group. For the no cancer group, the point estimate was 0.322, 1 minus 0.322 divided by the number of dogs in the no cancer group, so 945. So standard error, 0.0267. Okay. Define the test statistic. Once we have our point estimate standard error, the test statistic is going to be the point estimate, 0.0673, minus the null value of 0, which really doesn't matter if you do that or not. For this case here, subtracting 0 doesn't change anything. Divided by the standard error, 0.0267. So the test statistic is 0.252, or 2.52. For the p-value, I choose a normal CDF, and then 2.52 for the lower bound. Everything else, the upper bound 999. Mean, mu is 0, standard deviation 1, paste, times 2, and I get 0.0117. Now, this is less than 5%, so this would be a case where I would reject the null hypothesis. So we should reject the null hypothesis. There is sufficient evidence to show that the rate of exposure to 2,4-D is different for the two groups. That said, remember earlier that independence has not necessarily been met. Then this was an observational study. We can't prove causation with this study. And there could be other factors involved in terms of how these results came about.